All right, section 14.1. We're going to be simplifying rational expressions. What a rational expression means, rational just means fraction. So what we're going to be doing is we'll be working with expressions where there's x's on top and on the bottom in the numerator and the denominator. So let's get started with these. We'll just evaluate when x is equal to -2. And we'll take a look at a couple examples. Let's say we had 3x plus 1 over x minus 2. And let's say we had x squared minus 3x plus 2 over x squared minus 4x minus 3. Well, evaluate just means plug in a number for a letter. What we're going to do is whenever we evaluate, we always want to use parentheses. So we'll plug in -2 for the x's. So 3 times -2 plus 1 over -2 minus 2. Gives us -6 plus 1 over -4, which reduces to just -5 over -4, or 5/4. So simply just substituting in for x what the number is, and then solve it. For b, we'll plug in -2 for x. So -2 squared minus 3 times -2 plus 2 divided by -2 squared minus 4 times -2 minus 3. You could just use your calculator or order of operations. And this is 4 plus 6 plus 2. Over 4 plus 8 minus 3 is 12 over 9, which is 4/3. So when we're evaluating, it's just asking us to plug in a number for a letter. We use parentheses, order of operations, and that's what we get. One thing that comes up with rational expressions is the denominator, bottom of the fraction, cannot be 0. If it is, we say it's undefined. Let me show you some examples here. What if I asked you to find the values where the expression is undefined. Really, what I'm asking you to do is to set the denominator equal to 0 and solve. So first problem, if it was 3x over 2, there's no x in the denominator, so this is never undefined because there's no variable in the denominator. What if we had x minus 4 over 2x plus 1? Well, when is 2x plus 1 0? And that would be at negative 1/2. What if we had 4x plus 3 over 2x? We're trying to figure out when that's undefined. Well, you just make the denominator 0. And this one's simple. It's when x is 0. And then what if we had something where it's 2x squared plus 4 over x squared minus 2x minus 8? Well, we're trying to figure out when is our denominator 0. We've seen a problem like this before. We have to factor this. And remember, with factoring, we drew the x. We're looking for numbers that multiply to be negative 8 and add up to be negative 2. So we could use negative 4 and positive 2, and then we'll just factor. And set the factors equal to 0. That x is 4 and x is negative 2. All right, and then to wrap up this section, I want to show you something called simplifying rational expressions. when we're talking about simplifying rational expressions, we want to factor completely. Factor out a -1 and rearrange if subtracting. And then we also want to cancel common factors. See what I mean? The directions are just going to be to simplify. And let's start with x plus 2 over 2 plus x. First thing we could do, you can't just do this. That doesn't make any sense. You can only cancel if you're multiplying on top and multiplying on the bottom. But what we can do is we can just rearrange these. And you can see it's the same exact thing on top and bottom, which just translates to 1. It's similar if we had, let's see, like x minus 2 over 2 minus x. What we could do is just rearrange this one, and we just get x minus 2 over negative x plus 2. And this is what I was talking about over here, where it says factor out the -1. What we could do is if we take out a -1 from the bottom, we see it's the same thing on top and bottom. So these cancel, and you just get 1 over -1, which is -1. All right, what if we had 5 over 15x plus 75? Well, we could factor out a 15 from the bottom. And we just get x plus 75 divided by 15 is just 5. But one thing we could do to further simplify this is take out a 5 from the top and a 5 from the bottom. And you just get 1 over 3 times x plus 5. That's fully simplified. What about d minus 1 over d squared minus? Now, we saw a problem like this in our last class together, where we were talking about factoring special cases. And when you factor special cases, this is the same thing as just d squared minus 1 squared, or d plus 1 times d minus 1. We talked about this in the last section. Remember doing that? What we finished up with. Well, this is the same thing as this. So we're just left with 1 over d plus 1. Try a couple more here. What if we had x to the third plus 7x squared over x squared plus 2x minus 35. All right. Yeah, so in class we said we could factor out the top. We could actually take out an x squared from the top, and we're left with x plus 7. And the bottom we could factor. We're looking for numbers that multiply to be negative 35 and add up to be 2. So 7 and negative 5 would get the job done. But these cancel, and we're just left with x squared over x minus 5. One more. What if we had, say, 2x squared plus 5x minus 12 over 2x squared minus x minus 3. This is another one we have to factor. This one's a little trickier, so I'm going to show you the long way. We'll factor both the numerator and the denominator. The numbers that multiply to be negative 6 add up to be negative 1. And then for this one, they have to multiply to be negative 24 and add up to be 5. We spent a lot of time talking about factoring trinomials. Let's go ahead and factor these and then see what happens. All right, this is going to be the numerator. This will be our denominator. And you can see if we have the same terms on top and bottom, we could just cancel those. And we're just left with x plus 4 over x plus 1. The last problem that you need to know how to do is like a word problem. So it shows you it's a medical formula here. It says a child's dose of medicine C depends on their age, which we use A for, and an adult dose, which we use D for. Calculate a 7-year-old's dose if an adult dose is 1,200 milligrams. And the formula is C is equal to DA over A plus 12. I'll give you a second to copy that down. I'll just plug in the numbers and we'll figure it out. So the child's age is 7, so we're going to put that in for A. And it says the adult dose is D, that's 1,200. So the point is you just have to know the right letter to plug in for. And if we do this, we get 1,200 times 7 is 8,400 over 19. Which is 442.1 milligrams.